the bleeding reason your blood shares its iron with ancient ice. And in Antarctica's dry valleys, a glacier has been hoarding it for 5 million years while the ocean beneath your dinner plate quietly starves. Something inside your chest right now is chemically identical to what's locked under a glacier that's never once seen sunlight. And it's been hiding there since before humans existed. Every cell in your body runs on iron. Your blood carries it. Your brain burns it. Without it, you cannot think. You cannot breathe properly. You cannot survive. Now here's what they don't tell you. The ocean runs on iron too. Phytoplankton, the invisible organisms producing half the oxygen you're breathing right now, they need iron to grow. And across 40% of the world's oceans, there isn't enough. The fish you ate this week came from a food chain that starts with those organisms. The air you just inhaled came partly from that same chain. Something is stealing the iron, and it has been doing it for millions of years. In 1911, a geologist named Griffith Taylor walked through Antarctica's dry valleys and found a glacier weeping red. Not rust, not algae. Blood-red water pouring from a crack in the ice like a wound that never heals. He had no explanation. Nobody did. It took nearly a century to figure out what he was looking at. Beneath Taylor Glacier, buried under 400 meters of ice that hasn't shifted meaningfully in 5 million years, there is a lake, sealed, dark, saltier than the ocean. And it is absolutely saturated with iron. Iron dissolved from ancient bedrock, stripped grain by grain with nowhere to go. The glacier sits on top like a lid. Every few years, pressure forces a trickle of that brine up through fractures in the ice. It hits oxygen, it oxidizes instantly. It bleeds, blood falls, that's what they call it. And the glacier has been bleeding in secret for longer than your species has existed. Here's where it gets strange. Scientists assumed this was a one-off. An Antarctic oddity, something specific to the dry valleys and their bizarre chemistry. They were wrong. In 2013, researchers drilling into glaciers across Greenland, Iceland, and Patagonia pulled samples from glacial meltwater. They found iron everywhere, not trace amounts, massive concentrations. And in Greenland's fjords, where glaciers calve into the ocean, the water around the ice was blooming. Phytoplankton erupting in dense clouds precisely where the meltwater hit. The glaciers weren't just holding iron. They were releasing it, slowly, in doses that triggered life, which means when the ice is gone and it is going, the iron delivery system collapses with it. Here is what's actually happening inside a glacier, and it rewrites everything you thought you knew about ice. Glaciers grind. That's the mechanism. As they move even a centimeter per day, they pulverize the bedrock beneath them into powder so fine it becomes a mineral suspension. Glacial flour. That flour contains iron-bearing minerals, magnetite, pyrite, iron silicates. The grinding never stops. The accumulation never stops. But the glacier traps everything under pressure. The iron can't escape into rivers. It can't reach the ocean. It sits in subglacial lakes, in fractures, in films of water just a few molecules thick that exist between ice and rock at temperatures that shouldn't support liquid at all. For thousands of years, glaciers were the planet's iron vault. Locked. Sealed, the ocean downstream went without. Now here's what nobody expected. In 2020, a study in Nature Geoscience tracked iron isotopes from melting glaciers in Svalbard all the way into the open Arctic Ocean. The iron wasn't just present. It was bioavailable, the exact form phytoplankton can absorb and use immediately. Not inert mineral. Metabolically active iron delivered in pulses timed to melt cycles. The glaciers weren't hoarding iron randomly. They were dosing it. Releasing specific amounts at specific times in response to temperature rhythms that had stayed consistent for thousands of years. The ice was regulating ocean fertility. Deliberately, systematically. And we are dismantling the system. Glaciers globally have lost 28% of their mass since 1985. In the Arctic, summer sea ice volume has collapsed by 75%. In Patagonia, the glaciers feeding iron to the South Pacific are retreating faster than at any point in recorded history. The short-term effect looks like abundance. Meltwater surges. Iron floods the ocean. Phytoplankton blooms explode. Fish populations spike in the melt zones. But you're watching the vault being robbed, not a gift being given. Once the ice is gone, once the grinding stops, once the subglacial lakes drain and the iron supply depletes, the dosing ends. The blooms stop. The chain unravels. The ocean doesn't starve slowly, it crashes. And when the phytoplankton crash, they take half the planet's oxygen production with them. Scientists have now mapped over 400 subglacial lakes in Antarctica alone. Most have never been sampled. Most are older than the human species. Some are sealed so completely that the water inside may predate the ice age itself. We don't know what's dissolved in them. We don't know what's alive in them, but the glaciers do. And when they bleed, when that red water finally finds the light, the question isn't what's inside. It's what we just let out.